Okay, this video is to go over 3.4 arithmetic sequences. Arithmetic sequence is a list of numbers where the common difference, or where the difference between the consecutive terms is constant, known as the common difference, and common difference is always known as D. So this just says which one, or these are examples of different sequences. We want to know which ones are arithmetic. So looking here, I'm going to say, okay, this is you add 2 here, add 2, add 2, and add 2. So this would be a arithmetic sequence because you add 2. If I go to this one, I'm going to look over here. Looks like I'm adding 2, I'm adding 4, I'm adding 8. This would not be arithmetic. This one, I'm subtracting 8 each time, which means it is arithmetic. And then on this one, I'm adding all different big numbers, so that's not. Know that the domain is the natural numbers and the range is the terms of the sequence. So, a couple different ways you can write for sequences. For example, if this sequence is 3, 9, 15, 21, 27, and so on, you let n equal the term in the sequence. So let a of n equal the value of the nth term of the sequence. So for example, a of 1 would be 3, because 3 is the first term in the sequence. A of 4 would equal 21 because the fourth term is 21. Script notation, which is commonly used, is A5 would equal 27. The fifth term is 27. So recursive repeats the process over and over. It relates each term to the previous term, where explicit expresses the nth term of a sequence in terms of n. First thing we need to know is the recursive and explicit formulas for arithmetic sequences. So recursive formula is A1 to the first term and then A n equals A n minus 1 plus D. Okay, A to the n is the nth term. A to the n minus 1 is the previous term. And D is a common difference. Now for the explicit formula, you have A to the n equals A1 plus n minus 1 times D. This is saying A to the n is the nth term. That does not change. A1 is the first term. N is the term number. And D is a common difference. So let's do some examples. Given this sequence, write recursive and explicit rules 24, 27, 30, 33, and 36. So for the recursive formula, I'm going to have R, and you always have this little bracket, A1, which is 24. We need to find our difference. Let's go back and find our difference. We're adding 3 each time. So our common difference is 3. So for our recursive, we have A1 equals 24. And then we have A n minus 1. Oops, I messed that one up. It's A n equals A n minus 1 plus 3. So that would be your recursive rule. The explicit rule is going to be A n equals A1 is my first term, so 24, plus n minus 1 times my common difference, 3. Now, if I ask you, or there's times that you might have to actually solve this out and simplify, What you do with that is you just multiply this throughout. So you have 24 plus 3 times n is 3n. 3 times -1 is -3. So an equals, simplify 24 minus 3. An is going to equal 21 plus 3n. So we're going to do the same thing for this example. Given the sequence, write recursive and explicit rules. 6, 2, -2, -6, -10. So again, I got to find my common difference. I'm subtracting 4 each time. So my D is -4. So for my recursive, A1 is 6. I have AN equals AN minus 1 minus 4. Because it would be plus -4, so you can just put -4. Now, for my explicit, I have AN equals, A1 is 6, so 6 plus n minus 1 times -4. So I'm going to multiply that through to simplify. So AN equals 6, -4 times n is -4n. -4 times -1 is +4. Going to combine like terms. So AN equals 10 minus 4n. Now this example says, given the recursive formula, A1 equals 15, AN equals AN minus 1 plus 7, find the first 5 terms. So I know that A1 is going to equal 15. So I need to find A2. Actually, let's write it like this. Oop. Okay, as 15, and then we're going to write the next term. So then for my second term, I'm going to have 15 plus 7, which gives me 22. For the third term, I'm going to have 22 plus 7, which is 29. And for the fourth term, I'm going to have 29 plus 7, which gives me 36. And then I'm going to have 36 plus 7, which gives me 43. And those would be the first 5 terms. The next one says, given the explicit formula, AN equals 5 plus 3 times n minus 1, find A1 and A11. So I'm going to use this here. A1 equals 5 plus 3 times 1 minus 1. So A1 equals 5 plus 3 times 0. So A1 equals 5. Now if I'm looking for A11, I have A11 equals 5 plus 3 times 11 minus 1. A11 equals 5 plus 3 times 10. A11 equals 5 plus 30, so A11 is 35. Now this one says, write an explicit formula for the recursive formula. A1 equals 13, AN equals AN minus 1 plus 7. So I'm writing the explicit formula. Okay. So I'm going to have AN equals, my A1 here is 13 and my common difference is 7. So AN equals 13 plus n minus 1 times 7. So we're going to go ahead and simplify this. So I'm going to multiply the 7 throughout. So 13 plus 7n minus 7. So A of n equals 6 plus 7n. This says, write the recursive formula for the explicit formula. AN equals -5 plus n minus 1 times 2. So my A1 is going to be negative 5, and my common difference is 2. So to write that formula, I have A1 equals negative 5. AN equals AN minus 1 plus 2. Hopefully that helps you understand a little bit better.